Hello, my name is Josie Roundestvet, and I'm going to do problem 1, which says, according to NASA, during a space shuttle launch, the shuttle must reach a velocity of 8,000 meters per second in 8.5 minutes. If we assume that the movement is straight up, which it really isn't, what is the required acceleration and how far will the shuttle travel during this time? So what is the required acceleration? Okay, first I write down the information I know. So the velocity equals 8,000 meters per second. T equals 8.5 minutes. Is that all you know? According to NASA, during a space shuttle launch, the shuttle must reach a velocity of that. If we assume the movement is straight up, what is acceleration? So we're trying to find A. A equals question mark. So we need an equation with VT and A. So this is my equation sheet that I made with the different equations. And I'm gonna look for one with VT and A. Okay, let's see. Okay, so the average acceleration one has A average, which is that what this is? Yeah, I'm gonna assume it's average acceleration, so I'm gonna use the equation A average equals V2 minus V1 over T2 minus T1. It's this one, average acceleration right here. That's the equation I'm using. Okay. So then plug them in. So A average equals the V2 is final velocity equals 8,000 meters per second minus initial velocity, which starts from rest, I'm assuming. Does it say that, maybe? I think it starts from rest. T2 minus T1. Okay. T2 is 8.5 minutes. Minus the initial time of 0 seconds. So then So then 8.5 has to be converted. Okay, yeah. Okay, I'm converting T from 8.5 minutes to seconds, so that meters per second, and then the units match. So 8.5 times 60 seconds in a minute is, oh my gosh, is this video on YouTube? I'm like scratching my eye, sorry. 510 seconds. Okay, so 510. And since they're both minus 0, that just cancels out. So you do 8,000 divided by 510 seconds. So the average acceleration equals 15 point, I'm just doing it on my calculator, 15.68668627 sig figs. The most sig figs is 8.5 minutes, 2 sig figs. So 16 meters I was confused because I was canceling out my units like this. seconds, but then I thought seconds would cancel and acceleration is seconds squared, but I realized seconds is on the bottom. So 16 meters per second squared. So for the first part of the problem, if we assume that the movement is straight up, what is the required acceleration? I got 16 meters per second squared as the required acceleration. Okay, now I'm gonna do the second part of the problem. How far will the shuttle travel during this time? So, okay. How far will the shuttle travel during this time? Okay, so I need a equation. Okay, so now I have V equals 8,000 meters per second. T equals 510 seconds. A equals 16 meters per second. Or would I round it to 3 sig figs since I did 510 seconds? I'm gonna keep it at 2 sig figs. Okay. I don't know what to think about that. I'm gonna do 2 sig figs. Okay. How far will the shuttle travel during this time? So distance is what we're solving for. So now I'm looking for an equation that uses V, T, A, and X on my equation sheet again. Or multiple, maybe, I don't know. V, T, A, and X. Okay. A V equals VO plus AT. It's constant acceleration. Displacement with constant acceleration. But I've gotten the same thing if I did constant acceleration. V equals VO plus AT. What was I looking for? What is the required acceleration? I don't know if I can keep like doing this long. What is the required acceleration? So that's the, so if I did V equals, okay, wait, so I knew V. So if I did 8,000 equals 0 plus A times 510 seconds. I would get, I'd get the same thing. Okay, I just got confused here. What I just did was that first I'd use the average acceleration equation, then I saw the constant acceleration equation, and I was like, is that the one I'm supposed to be using? And then I resolved it with the constant acceleration equation, and I got the same thing. So now I'm gonna calculate displacement with constant acceleration. That's why I got confused, because it wasn't average, it was constant. Okay, so let's see what my options are. V, T, A, and X. So I have V, X, and T, and I have X, V, T, and A. Okay, let me make sure there's not another one. Oh, are we disregarding gravity? If we shouldn't straight up, what is the acceleration? I disregarded gravity, I guess. Okay. So I'm gonna use that one. So I'm gonna use X minus XO equals VOT plus 1/2 AT squared. Okay, so X minus XO, where we have the final and the initial 0, so I'm gonna cross off the initial. So X equals the initial velocity was also 0. 0 times t equals 0, so I'm going to cancel off VOT. Okay, so now I have x equals 1/2 AT squared. Oh, now I'm just gonna plug in my number. So x equals 1/2, oh yeah, okay. 1/2 A, which is 16 meters per second, times t, which is 510 seconds squared. And so I would get um, 510 seconds squared is 260,100 seconds squared. Somehow there's still seconds left in my, 16 meters per second squared. Okay, so then my second units cancel out. So times 16 meters per second squared equals 4161600 divided by 2 because of 1/2 equals 2080800 is x. So now that I have x, I'm going to do sig figs. So and it's in meters, which I don't think it matters. Okay, yeah. So I'm gonna have x equals 1, 2, 3, 4, 5 with 5 zeros. 1, 2, 3, 4, 5 commas. 2,100,000 meters is x. And this is where I got that equation from on my equation sheet. Did I show that? I don't remember. And this, so my final answers for problem 1 are 16 meters per second squared and 2,100,000 meters. 2,100,000 meters is how far the space shuttle traveled in 8.5 minutes. And there's my work. Thank you.